Einstein's derivation, 1905, of the energy-mass-equivalence equation, E equals mc². Introduction. Does the inertia of a body depend upon its energy content? The Einstein's paper was received by the German journal, The Annals of Physics, on September 27, 1905, and published in the journal on November 21, 1905. The energy-mass-equivalence paper is very short, 3 pages, from 639 to 641, in the Annals of Physics. It contains lots of implicit information, which Einstein did not bother to make it explicit. Mathematically, the paper makes use of simple algebra. There are a total of 8 mathematical expressions in Einstein's revolutionary paper. In the following I will use different notations, as is currently used, from the one used by Einstein. The mathematical expressions, however, I number in accordance with Einstein's paper. In his energy-mass-equivalence paper, written in September 1905, Einstein makes use of the results in his previous paper, often referred to as the special relativity paper. Albert Einstein. On the electrodynamics of moving bodies. The Annals of Physics. Received on June 30, 1905, published on September 26, 1905. The energy-mass-equivalence equation, the most celebrated equation in physics, Einstein, in his 1905 paper, gives in an implicit form. You do not see explicitly the energy-mass-equivalence equation in that paper. But it is there, implicitly. Instead, Einstein gives a descriptive information, in the following form: the mass of a body is a measure of its energy content. If the energy changes by E, the mass changes, in the same sense, by E divided by the velocity of light squared. Also, Einstein does not explicitly discuss the conditions under which the energy-mass-equivalence equation can be used. But the conditions are there, implicitly, and for Einstein, they are quite obvious. The energy-mass-equivalence paper, written in September 1905, by a 26-year-old Einstein. He had turned 26 on March 14, 1905, is a highly intuitive work. The major characteristic of almost all Einstein's work, and of Einstein's thought, in general. The energy-mass-equivalence paper is essentially the thought experiment, the term introduced by Einstein himself into physics. A celebrated Serb-born American scientist, Nikola Tesla, was also a thought experimentalist, saying, "Invariably my device works as I conceive that it should. And the experiment comes out exactly as I planned." Newton, Tesla, Einstein. The Gospel of the Achievers. Speaking of Einstein and Tesla, let Newton join them. The record shows that the 3 geniuses were loners, finding it hard to make friends, and finding it quite easy to make enemies. They were of similar scientific temperaments, easily moved into the fierce battle for truth. Although considered to have been fallen the victim of the superiority syndrome, Newton, the pride of the English, the British, the human race, did show the ultimate unpretentiousness by saying this phrase: "If I have seen further, it is by standing on the shoulders of giants." Newton had written this in his letter to Robert Hooke on February 5, 1675. February 5 is my birth month, and my birthday, 1675, is the year long before I hopped into this world. I refer to this as my time mapping game, dating back to my childhood. The Newton phrase is still echoing through time. It has become the sort of the gospel of the achievers. Nikola Tesla, the pride of the Serbs, the Yugoslavs, the Americans, the human race, was a flamboyant man, which could have hardly helped him to have been liked as a person. Yet he had lived a modest life, plagued with chronic financial problems. Albert Einstein, the pride of the Jews, the Germans, the Swiss, the Americans, the human race, was actively aware of his superior intellectual capacity. He had lived the life of being continually exposed to the rain of the arrows of hate. Yet, he survived it, gloriously. Both Tesla and Einstein had subscribed to the wisdom of Newton, having had praised the work of their predecessors. The three arrogant geniuses did show, however, the trace of humbleness, giving to the arrogance a somewhat good name, so to speak. Einstein's thought experiment. Intuitive derivation of the E equals m multiplied by the velocity of light squared. Physical body, emitting. To counter-propagating light beams into inertial reference systems. Einstein's general assumptions in the Energy-Mass-Equivalence Paper. In his paper of 1905 on energy-mass equivalence, Einstein makes use of the following assumptions. Principle of relativity. The physical laws are the same in all inertial reference systems. By eliminating the concept of ether in physics, Einstein states that the velocity of light is constant, and the same in all inertial systems. Conservation of energy law. Relativistic law of the transformation of electromagnetic wave energy. Relativistic Doppler effect. Newton dynamics as the limit of relativistic dynamics, for the case of low velocities. Einstein starts with the assumption of having two inertial reference systems, a stationary reference system A, and a moving reference system B, whose origin moves parallel to axis, xa, with constant velocity, v. He assumes to be having a plane electromagnetic wave, light beam, propagating at the angle with respect to axis, xa, and having energy, EW. Einstein makes use of the principle of relativity. The physical laws are the same in all inertial reference systems. He also states, eliminating the concept of ether in physics, that the velocity of light is constant, and the same in all inertial systems. Based on his relativistic Doppler effect, he discussed in his previous paper, the special relativity paper, Einstein obtains. This is the first mathematical expression in Einstein's Energy-Mass-Equivalence Paper. Einstein now assumes to have a body at rest in the system A, with mass ma, and with total energy Ea, and in the system B, with mass Nb and total energy Eb. He assumes that the body emits simultaneously two counter-propagating light beams, plane waves, at the angle with respect to axis xa. By using two counter-propagating light beams, Einstein excludes the recoil movement of the body, both in the rest system A and in the moving system B. Einstein obtains, making use of the conservation of energy principle in both systems A and B. Einstein's intuitive approach. Now, Einstein introduces the kinetic energy of the body with mass mb in the moving system B. Here, a 26-year-old Einstein introduces the constant C intuitively and says, it is clear that the total energy difference, EB-CA, can differ from the body's kinetic energy, EK, with respect to the other system, system B, solely by an additive constant, C, which depends on the choice of the arbitrary additive constants of the energy, EB and EA. We can, therefore, put, since C does not change during the emission of light. From 5 and 6, Einstein obtains Einstein's blissful moment. Sometimes in September, before 27, 1905. From 7. Keeping in the binomial expansion of the relativistic factor only second-order quantities, Einstein obtains the last mathematical expression of his 1905 paper, describing his revolutionary energy-mass-equivalence equation. The history of physics has been changed forever. Einstein gives the physical description of 8, which is essentially descriptive information on energy-mass equivalence. The mass of a body is a measure of its energy content. If the energy changes by E, the mass changes, in the same sense by E, divided by the velocity of light squared. The very last sentence of Einstein's paper reads as follows. If the theory agrees with the facts, then radiation transmits inertia, mass, between emitting and absorbing bodies. The term, transmitting of inertia, mass, between emitting and absorbing bodies, could probably be seen in some wild footloose fancy-free thinking, as the teleportation travel. Being a professional physicist, I would rather die than discuss that openly. Einstein walks back home, with a victorious smile on his face. I could easily imagine this. Having written the paper, a 26-year-old Albert Einstein mails it now, from Bern, Switzerland, to the office of the Annals of Physics in Leipzig, Germany. The paper is short, 3 pages. A young Einstein is probably in a burning passion to reveal to the world his mighty intellectual capacity. Making it a short paper was a good way to go. Quite happy, off he goes back home with a victorious smile on his face. There, his loving wife, Mileva Marich Einstein, is waiting for him, and smiling back. The paper is received by the journal on September 27, 1905. Paul Drud is general editor. These are the times when the submitted papers to the journal are not journal peer-reviewed. Later on, in his life, Einstein was a victim of a brutal journal peer-reviewing process in the USA, when his paper was rejected for publishing by a referee. You heard me. One Einstein's paper was rejected by a referee. Should I say, the referee? Today, as we physicists know well, the more the paper is revolutionary, the more difficult it is to publish it. If Einstein were to publish his revolutionary paper today, I could easily see it being rejected by the referee. I always keep in mind that the paper was written by a 26-year-old Einstein, in the state of the confident high intuition, almost as if God spoke to him. This is similar to the case of a young 24-year-old Isaac Newton, when he was postulating the principles of the classical physics, or a 27-year-old Niels Bohr, when he was working on his atom model. It has been proven that the revolutionary physics mostly comes from young physicists. The application limits of Einstein's 1905 energy-mass equivalence equation. The very last mathematical expression in Einstein's paper is Einstein in his second sentence from the end of his paper says this. Perhaps it will prove possible to test this theory using bodies whose energy content is variable to a high degree, e.g., salts of radium. It is possible, it seems to me, that Einstein was inspired to write this paper by the experimentally observed radioactive disintegration of the salts of radium. Currently, the energy-mass equivalence is the central concept of the big science projects, the nuclear fission, and the thermonuclear fusion projects. Einstein, who was a mathematical physicist, was always deeply concerned about experimental testing of theories. But he was aware that experiment itself could be wrong. On one occasion, Einstein was reminded that the experiment had disproved his theory, on which Einstein retorted, the experiment will go away. Later, Einstein would state that theory, thought experiment is the best experiment. The correct theory, as Nikola Tesla said, will always, invariably, be proved by experiment. Generalization of Einstein's energy-mass-equivalence equation, 1905. More general case of energy-mass-equivalence equation is equation C is applicable for the mass-carrying particles with subluminal velocities. If the velocity tends to be close to the velocity of light, then relativistic factor tends to infinity, making equation C inapplicable. The concept of infinity has been plaguing mathematical physics since the times of Newton. In mathematics, the concept is comfortably dealt with, so to speak, but in physics, it is the devil. Physicists always try, mostly successfully, to find some physical process that kills the devil. The equation C is not applicable for the massless m0=0 physical entities, such as a photon, which, in addition, is a luminal particle. It moves with the speed of light. For the massless m0=0 and luminal v=c particles, the equation C is generalized into the following form. Equation D is applicable for the massless m0=0 and mass-carrying particles, and for the luminal v=c and subluminal motions. Einstein walks the road of the fame and glory. The Energy-Mass-Equivalence Paper is published by the Annals of Physics on November 21, 1905. The world of physics was, and it still is, stunned in awe as to the depth of the Einstein physics. Albert Einstein, a 26-year-old physicist, a clerk in the patent office in Bern, Switzerland, had been walking the road of the fame and glory up to his flatline day, April 18, 1955. But his life was not completely the rose garden. The Einstein Phobia. Throughout the decades since 1905, there has been the Einstein Phobia, the effort to dismiss Einstein's work as being wrong, or downright plagiarism. It has been, invariably, proved that the effort itself is wrong. With the rise of the Internet, and with the ease of promoting whatever you want, and acquire the paltry fame for it, you have an easy access to tons of misleading presentations on Einstein's work with misleading titles. They are even done by laymen who mix their acquired false information on the topic with their comprehension of the topic, showing, in that way, shamelessly, their ignorance. The Internet should be used as an excellent vehicle for solid public education. For example, Einstein generalized the Newton physics, and you can refer to it as the Einstein physics. It is misleading to use the title "Newton was wrong" for the purpose of acquiring ever more viewers. The PAULI syndrome. The work is not only right, but it is not even wrong. Wolfgang Pauli, 1900 to 1958, qualified the physics research as right, wrong, and not even wrong. The work is not only right, but it's not even wrong. He was often lovingly referred to by his colleagues as the wild wolfie. The attacks on Einstein's work throughout the decades are mostly in the domain of the PAULI syndrome. They are not even wrong. Wolfgang Pauli was known by his contemporaries as the conscience of physics. He was merciless and all-come razor direct, almost brutal, in his comments on bad works in physics. Only in the presence of Einstein, wild wolfie would become somewhat tamed. Pauli received Nobel Prize in Physics in 1945, after having been nominated by Einstein. Einstein referred to Pauli as his spiritual heir. In 1958, Victor Frederick Weisskopf, 1908 to 2002, becomes an executor of Pauli's intellectual estate. Victor Frederick Weisskopf and Albert Einstein were colleagues, friends. They played music together. Vicky tells me, 1992, says Stefan, the following story. If you wanted to prevent Pauli from his possible brutal critique of your work during your presentation of it, you would first go to his office to discuss with him your paper and hear his comments. During your presentation, instead of giving aloud comments, Wolfie would just murmur to himself, "I told you, that's nonsense." See in what follows, Physics and Society. To prevent your global embarrassment of probably having Pauli publicly criticizing your work, you would write him. He would write you back with his merciless comments, but Pauli would never go publicly about it. The logical error. The fallacy of Petitio, Principii or Circulus and Probando. Einstein's Energy-Mass-Equivalence Paper, 1905, has been criticized by a number of the doubting Thomas physicists, not completely silenced even today, accusing Einstein of making, in his derivation of energy-mass-equivalence equation, the logical error. The fallacy of Petitio, Principii or Circulus and Probando. In a simple form, this is the argument. The doubting Thomas physicists start with Einstein's premise, the equations 5 and 6. The doubting Thomas physicists claim that the conclusion of Einstein's paper 8 is already contained in his premise 5 and 6. In proving their statement, they themselves fall victims to the logical error, fallacy of Petitio, Principii or Circulus and Probando. With all due respect for their intellectual effort, I would say, using Pauli's phrase, their statements are not even wrong. Einstein writes 5 and 6 based on his intuition, as if God spoke to him. Here are more details. Einstein's intuitive approach. Now, Einstein introduces the kinetic energy of the body with mass, mb, in the moving system, b. Here, a 26-year-old Einstein introduces the constant c intuitively and says, it is clear that the total energy difference, EB minus CA, can differ from the body's kinetic energy, EK, with respect to the other system B, solely by an additive constant, C, which depends on the choice of the arbitrary additive constants of the energy, EB and EA. We can, therefore, put, since C does not change during the emission of light. Einstein's 1905 paper is of an intuitive character, as if God spoke to him. As such, Einstein's thought experiment was put to be tested by the brick and mortar experiment. And it was proved correct experimentally.
The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Kach and Walton in 1932 experiment.
Bohr, in 1913, intuitively, as if God spoke to him, proposed the model of atom, currently known as the Bohr model of atom. The model was proved correct experimentally. When you are talking about intuitive statements, you do not really want to investigate where they come from, unless you want to involve a psychological analysis or even God. Einstein, at the age of 67, 1946, in Princeton, New Jersey, writes his autobiographical notes, his own scientific obituary, as he said. Here, Einstein is accused, again, by some for not talking about his private life at all. In his notes, Einstein says this about Bohr's great intuition, Bohr's unique instinct and sensitivity to discover the principal laws of spectral lines and of the electron shells of the atom, together with their significance for chemistry, appear to me as a miracle, and appears to me as a miracle even today. This is the highest form of musicality in the sphere of thought. What a beautiful statement by Einstein on Bohr's work, his intellectual adversary. To the musicality in the sphere of thought, I would add here the Pythagoras musicality of the harmony of the spheres. Einstein's energy-mass-equivalence equation. I do see. The energy equals mass multiplied by the velocity of light squared. E equals mc². As the work of the sage, the wisdom that emanates from Einstein's intuition. V. Alexander, Sasha, Stefan. Bohr's atom model. I do see the Bohr atom model as the work of a magus, the magic that emanates from Bohr's intuition. V. Alexander, Sasha, Stefan. The early development of quantum physics is an excellent example of intuitive approach in physics. The intuitive conclusions of some physicists were frequently taken as granted by other physicists in their work. This is a logical error, but not a methodological one. Contrary to popular opinion, the progress of physics is based not only on logical reasoning, but also on intuition and, in some extent, on emotion. Probabilistic quantum physics has a spectacular success. Quantum physicists, with Niels Bohr as the leader, have accepted probabilistic method as a mathematical method in the description of the microworld. Einstein was against the probabilistic method. He appreciated the success of quantum mechanics, but would say, the more success the quantum theory, the probabilistic quantum theory has, the sillier it looks. Einstein did not offer any contribution to the development of non-probabilistic quantum physics, but he firmly believed that it was possible to do so. And he warned by saying something like this: "We will see whose intuition wins." Well, let's see. Einstein explains his energy-mass-equivalence equation. August 2, 1939. Princeton, New Jersey, USA. Einstein explains his energy-mass equation, E=mc², which he calculated in September 1905, probably in the village of Kach, as he was visiting with his Serb-born wife Mileva Marić Einstein, her family there. Kach is in the present-day Serbia, Yugoslavia. He published his result, the most celebrated equation in physics, on November 21, 1905, in a German science journal, Annals of Physics.
It follows from the special theory of relativity that mass and energy are but different manifestations of the same thing. A somewhat unfamiliar conception for the average mind. Furthermore, the equation E=mc², in which energy is put equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Kach and Walton in 1932 experiment.
Legend has it, the village of Kach, Serbia, Yugoslavia is the birthplace of the most celebrated equation in physics, energy-mass-equivalence equation, E=mc². Einstein's paper, does the inertia of the body depend on its energy content? Energy-mass-equivalence, E=mc², was received by the German journal, Annals of Physics, in Leipzig, Germany, on September 27, 1905, and published in the journal on November 21, 1905. This paper was submitted to the Annals soon after his visit to Serbia. Hence, the legend has it that Einstein got his idea on the energy-mass equivalence in the village of Kach, Serbia, Yugoslavia.